All right, what's going on, everybody? It's Derek. We're back here in week 9, where we're going to do a quick recap of encryption. And we're also going to get into management and logging, which is huge for me because I actually, really kind of work a lot with logging and finding out root causes of problems in my actual job. So let's go ahead and get to it. But first, guys and girls, I'm just going to throw this out there. It wasn't necessarily the best night for me last night, sleep wise, energy wise. So we're feeling a little bit out of it today. So my energy levels maybe aren't as high as they potentially could be. I apologize. But when you make a commitment to do something, you do it regardless of if you feel like it or not, per se. Okay, in the same way that you're committing to taking and passing this exam, there's going to be days where you don't feel like studying, you just don't feel like doing things, but show up and put in the time, and you're going to be glad you did ultimately after you pass your test on your first try. All right, so let's go ahead and get into it here. So, in reviewing encryption, we want to remember that encryption is a standard security best practice, and it's likely going to be used at pretty much any organization or company you'll ever work at. It's that important. Uh, and within AWS, we have Key Management Service, KMS, being the primary encryption service that's going to help us store and generate encryption keys. Okay? So within KMS, we have customer master keys, CMKs. We've got data encryption keys, DEKs, but the CMK is what actually generates and then encrypt and decrypts the DEKs. Okay, a DEK is what's actually used though by AWS services to encrypt your data, right? So we've got that envelope encryption, we've got the DEK encrypting data, we've got the CMK encrypting the DEK. All right. Unfortunately, you can't recover your CMK if it's deleted, so you're going to have to use a new one. So be sure you're keeping tabs on those. And you can gain access to a KMS key, right, a CMK, from either a key policy, an IAM policy, or a grant. Okay? So key policies let you define who can use and access specific KMS keys, very similar to IAM policies. Except key policies are tied to the CMK, whereas of course IAM policies, are tied to like users, groups, and things of that nature. But you also have grants, which can control access to your CMKs that are stored in KMS by delegating a subset of your permissions to someone to let them use the CMK in a specific way, as opposed to like making key policies and managing those. Okay. All right, so data should be encrypted both in transit and at rest. So in transit, you're going to be looking at using things like SSL, TLS, right? So secure site certificates, things of that nature. And then at rest, so like server-side encryption, you've got S3. You can use KMS. You can encrypt EBS volumes. You can encrypt RDS database snapshots. You can encrypt a ton of things at rest. All right, so you should be utilizing that whenever you can. Cloud HSM is a physical tamper-resistant appliance that protects cryptographic material and encryption keys. And it's going to give you a large degree of control over your encryption processes and materials, but it's not really very commonly used. Similar to like maybe AWS Snowball kind of family isn't really used because these physical hardware devices, anything physical with cloud computing generally isn't used very often. That kind of defeats the whole purpose. And then we have AWS Secrets Manager, which lets you essentially manage credentials for services and applications as opposed to managing keys. It manages credentials. And these secrets are going to be encrypted and managed by KMS using the encryption algorithms in there. And then I kind of like to think of Secrets Manager as a vault for your credentials instead of storing them in the application code itself. Because if your code, or maybe you have CloudFront templates that, or CloudFormation templates rather, that get exposed and they have just plain text references to your credentials, that could be a problem. As opposed to making a reference to Secrets Manager to go out and grab those credentials. Okay. All right. So management and logging is on the agenda today. And these are very important, especially as an architect, because you're kind of responsible for a project's implementation from start to finish, and then even ongoing kind of maintenance and fine tuning of that application and architecture, right? So it's important to have at this associate level, anyways, a high level overview of how you would manage a given architecture. And also, if things happen, which they probably will in one way, shape, or form, how can you get to the bottom of it? How can you figure out, the root cause? How can you maybe learn from that and analyze that? And you're going to find that you can use logging for all that. So we'll take a look at logging as well. So let's get into it. We've got some key concepts here. And we've mentioned this multiple times before, especially in the security section, but when giving permissions to users, you should always follow the principle of least privilege, which, again, as a refresher, means that someone only gets enough permissions to do what they need, like their job function and nothing else. Okay. You want to consider organizational compliance standards. So, for example, maybe you're working with like a healthcare organization and you've got to work with like HIPAA compliance regulations, or maybe you work with like a financial institution and you've got to comply with FINRA regulations. So, wherever you end up working, they're going to have different compliance standards that you need to fall in line with. And you want to utilize multiple layers of authentication, like using MFA on top of passwords for access, securing your like edge networks and your instances and your subnets and your VPCs, things of that nature, right? Multiple layers of authentication and security in general. Okay. All right. So CloudWatch is one of two services that we are going to talk about quite heavily today. And CloudWatch is what monitors what is happening with your infrastructure. Okay. So if we think about what's actually going on, what's happening, how is it performing, what's it doing, we can think of CloudWatch. Okay. It's like a window into our architectures and our applications. All right. So CloudWatch consists of a few different sort of services that help make it as powerful and utilitarian as it is. We've got logs, which of course we're going to have logs. They are centralized areas to store log data. You've got metrics, which are time ordered data points, or you could think of them like variables, for example. You've got Event Bridge, which is what monitors for specified events and then will trigger actions when those events occur. So, like for example, maybe you're monitoring CPU utilization on some of your instances, and then you want to trigger an auto scaling group to do something when CPU utilization goes over 75% or whatever. Alarms trigger notifications based on metrics, and then you can, of course, use that with SNS to send out notifications. You've got dashboards, which are going to be kind of what brings everything together. They're just nice visual tools that help you visualize what's happening based on your collected metrics. Okay? And then you've got insights, which help you to analyze logs that are collected from either logs, containers, or even Lambda. All right. And CloudWatch alarms actually have just three states. Okay, they're relatively self-explanatory. You've got OK, which is the metric that's being monitored is within the defined threshold. Okay. You've got alarm, which means that the metric is outside of the defined threshold, right? One way or another, it's within or outside of the acceptable bounds. Okay. And you've got insufficient data, which means that maybe you just started this alarm and it hasn't had enough time to kind of collect data and actually see what's going on. Okay. So most of the time you're going to see either OK or alarm. But sometimes if you're running into issues because you've got, maybe some new alarms or things that you're kind of tweaking, then you might see insufficient data. All right. So Event Bridge, as we kind of alluded to here a minute ago, okay, Event Bridge is what actually monitors how your systems are performing and what's actually happening with them. Okay, it's got additionally, it's got a few components to it as well. It's got rules, targets, and event buses. Okay? So a rule is basically going to act as a filter for incoming event traffic, and then it's going to determine where to send that traffic. Okay? Now, where it sends that traffic is dependent on your targets, which is where events from your rules are sent. And it can be things like maybe from, SQS, you could maybe send it to Lambda function, you could send it to like an SNS topic or others as well. So it's very helpful in, kind of sending out notifications, okay, or traffic rather. And you have the event bus, which is the component that kind of behind the scenes actually receives an event from a rule and then goes ahead and sends that out to whatever targets you specify. All right. So that's kind of how EventBridge works. It used to be called CloudWatch Events or something along those lines, but they kind of rebranded it to EventBridge. So it kind of sounds like its own service, but it's definitely designed to work with AWS CloudWatch. Okay. So we have, on the other hand, AWS CloudTrail. And this is very similar to CloudWatch, except where CloudWatch is looking at what is happening with our architecture, CloudTrail is, looking at who is doing something or who did something, okay? It tracks API calls or user access, okay? So when you're thinking or even asked about, how to track, again, API calls or user access, start thinking of CloudTrail because you will be asked about CloudTrail on the test at least once, probably multiple times. So get familiar with that. But again, it monitors API calls and actions, otherwise known as events, that are made on an AWS account, and it gives you the following metadata, right? So where, so the source IP address that did whatever event, okay, whatever action. It's got when, so it's kind of like a timestamp of when this event actually happened. Who, so maybe it was an IAM user or a specific AWS service that did it. And then what, so like what region, what resource was affected, what action actually happened, okay? And it's important to remember too that, API calls aren't necessarily just something that's done kind of abstractively, like by, maybe programmatic access. Of course, it can come, programmatically, but you can also have API calls come from SDKs. You can have them come from the AWS console. You can even have them come from other services talking to your services that are being kind of watched. All right. So basically, any kind of action will be potentially monitored on CloudTrail if you set up that trail. Okay. So speaking of that, trails are what you actually set up to monitor kind of specific things, and they're stored in S3, and they can be analyzed with Amazon Athena like any other data in S3. Okay. And again, Athena is just a serverless SQL-like service that's primarily used to analyze data stored in S3 buckets. All right. So, CloudTrail integrations. Of course, with a service as powerful as CloudTrail, you can use it to kind of talk to, communicate with, and work with many other services and areas in your AWS architecture and applications. So, we want to remember that trails are the fundamental unit that capture API requests. Okay, so it's something you set up and you specify that it's looking for certain, again, requests or events in certain areas, and it will start tracking those in something called a trail. Okay. It integrates really well with S3 by storing log and data files that you have collected from your trails. It integrates with logs, of course, by creating trails and then recording events that can be used in other services. Maybe again you analyze your logs. Maybe you send those logs to something like CloudWatch, right? You can deliver your logs to CloudWatch to be used with your metrics that you have set up. We can use CloudTrail integration. We can use CloudTrail with KMS, right, to add encryption to our log files that we're storing if we want to do that. We can of course use it with SNS to send out notifications to users or admins or other services of events via channels. Right? We can of course use tags to help compartmentalize our trails. So maybe we would just want to have trails in specific environments, maybe. And then of course events. So any API request from anywhere, like we said, maybe the CLI, maybe the SDK, maybe the console. Basically, any API request can be tracked with CloudTrail. All right. So it's very helpful, very utilitarian service. All right, so let's just look at how CloudTrail actually works, so you get a better understanding of what's going on here. And after that, we'll take a quick break because it's been about 15 minutes. All right. So in this top sort of uh, diagram up here, we are going to create a trail. All right. So what we're going to do is we're going to create our trail. We're going to then specify an S3 bucket that we're going to store those logs in for later use and analysis. And we have another few optional steps here before we actually finalize creating our trail. We can encrypt our log files with KMS like we alluded to earlier. We can set up notifications of new log files. So for example, if you have an SNS topic, you can subscribe to that to be notified when there are new log files created and put in this bucket. And then if you need to preserve the integrity of your log files to make sure that they aren't being tampered with or anything like that, you can enable log file validation. Okay. So once you specify your bucket and set these up if you want to, it then creates your trail. Okay. And once you create your trail, you have a few more configuration options to again integrate with some other services if you want. You can have CloudTrail deliver logs to CloudWatch logs for monitoring to again work with your metrics that you have set up. Okay. You can configure advanced event selectors if you have like a specific use case where you need to be really granular about monitoring a specific set of events. You could do that. And then, of course, you could add any required tags. Okay. Maybe your organization needs tags. It's not uncommon. And again, tags are really helpful for tracking costs. Okay. And then once you, specify those if you want, your final configuration is now complete. Okay, so we now have this trail here, all right, that we're ready to deploy and use to start monitoring API calls within our account, all right? So now if we come down here, all right, we've got our AWS Cloud trail here, all right? It's depositing logs into this S3 bucket, okay, that we specified up here, all right? So now what's happening is it's going to say, okay, for this particular trail, maybe we are parsing, doing something in Lambda, right? We're just parsing logic. We're doing something in Lambda, okay? Once we are monitoring, or once that happens, right, this trail is then going to send information about this, event that happened in Lambda to this S3 bucket configuration file, okay? And then once that happens, we're then going to send a notification to SNS about what happened here with Lambda, doing whatever kind of logic parsing we're doing, depositing something into our bucket configuration file. And then SNS is going to send out via email a notification saying that something did in fact happen here so that we're aware and cognizant of what's going on with our architecture, and in this case when we're kind of parsing through some logic using Lambda functions. All right, so that's kind of how CloudTrail works behind the scenes. You set up a trail, you say what you want to monitor, you deliver the log files to S3, and then you can go back and analyze those logs in your bucket, and then you will be notified of something happening whenever it happens. All right, so that's CloudTrail and CloudWatch in a nutshell. Let's take a quick 5-minute break here to let that all sink in, and then we'll come back and we'll pick it up from here. All right. We're about halfway through. We might be a little bit more than that. CloudTrail and CloudWatch definitely make up the majority of what we're going to kind of go into and go over today. But there's a few other things. So let's take a look. We've got AWS organizations, which are very useful if you have a bunch of different, users and departments that need access to services, because those are more than likely going to be in different accounts. Okay. So organizations allows you to manage multiple AWS accounts that you own. Okay. You have the option to enable consolidated billing to send one bill, or not one bill, to send just the bill from all of your AWS accounts up to one account. Okay, and we'll take a look at what that actually looks like here in a minute. But then, you can see which accounts are incurring which costs, because each account is just going to send its bill up to this root account. Okay, and then that root account sees the bill from all these other accounts. All right. But then that one account pays for everything. Okay. You can automate new account creation and then automatically apply the appropriate permissions within AWS organizations. You can automate your infrastructure deployment within specific accounts. So there might be a time where you want to set up an account. Maybe it's for like a test, some kind of test environment, and you automatically want to deploy very small EC2 instances and maybe database instances that you can kind of play around with in your test environment. All right. Service control policies are exclusive to organizations. Okay. And basically, they set guardrails for all the accounts in your organization. Okay. Not users or roles, accounts. All right. And they only kind of filter things and say what is possible to do, but they don't actually add permissions to accounts themselves. So you still need to specify, which IAM policies are going to be allowed within each account. But service control policies will basically tell you which policies you can, give out. But again, they won't actually ever add permissions, okay? As a best practice, you should try to avoid attaching service control policies to the root account of your organization, because each organizational unit, which again we'll talk about here in a second, and subsequent account will inherit the SCPs from the higher level on the hierarchy. Okay. So basically, if you attach an SCP to the root account of your organization, it's going to apply to every OU and every single account within your organization. Okay, and that can cause some conflicts. It can cause some unwanted changes and unwanted effects, and it's just the best practice to not do that, but instead kind of apply things to your OUs. All right. So what we've been talking about root account and OUs and whatever. What does it actually look like? Okay. So we have up here the root account. All right. And within here, within this root account, we've got a few different OUs. Okay, we've got a foundational OU, so OU organizational unit. We've got production OU, pre-prod OU, staging, and sandbox OU. Okay, each of these OUs has two accounts. So prod OU, tenant 1 and 2, that's account 1, account 2, account 3, account 4, so on and so forth. But you can also have nested OUs. So if you'll notice over here, foundational OUs, you've got the infrastructure OU, which has your network account and your shared service account. And then you've got the security OU, which has the security and the log archive accounts. Okay. So this is what an organization would actually look like. You've got the root account. You've got the some OUs up here. And then again, you can also have nested OUs. And then individual accounts are what actually live within OUs. Okay. So as I mentioned earlier, you can enable consolidated billing, which basically will send the bill from network account all the way through 10 and 8. So what is this? 6, 8, 10. So all 12 accounts here send their bill up to this root account, and the root account can see what the cost of each account is, but it just pays for all of them outright. Okay, so maybe this root account is kind of managed by someone from like your accounting department or one of your executives, something along those lines. But basically, this root account would pay for everyone. Okay. And as I mentioned earlier, with service control policies, you will inherit the SCP from the higher levels on the tree. Okay, so if I were to apply an SCP here in the root account, saying that it's only possible to create EC2 instances up to a certain size, let's just say like a size 6 out of 10 to just keep it super simple. I could not create any instances larger than a 6 on any of these accounts. Okay, that doesn't say, maybe over here in our staging and sandbox OU, maybe we only want to have like, size 1 and 2. Whereas in like our production kind of OU, maybe we want to have like, size like 5 or 6, right? So some kind of heavier duty ones. But it's not going to let me provision any instances that have a size of like 10, for example. Okay. However, if I were to apply that same OU to just staging and sandbox, I think we said we can't create it over like a 6 or a 7 size, whatever I said. Let's just say 6. So now staging and sandbox could create instances up to a size 6. Okay. If I applied that SCP to staging and sandbox. Okay. But if I applied another SCP to pre-prod and prod that said, oh, you can create up to an 8 in size, well, then now I could create an or up to an 8, and 10 at 1, 2, 3, or 4. All right. That SCP would not affect tenants 5 through 8 because, they're at the same level of the tree. They're not inheriting anything from, the root or anything above it. Okay. And the same concept goes here. I could apply an SCP to the foundational EU, which will then be inherited by infrastructure and security, or I could apply, an SCP, separate SCPs to security and infrastructure. Okay. So again, SCPs just allow you to set guardrails on what's possible, but they don't actually say what, you are going to actually do. They don't actually give permissions. They just say what's possible. Okay. So hopefully this is helpful to visualize organizations because you'll definitely be asked about them. And if you're working at any kind of company that uses multiple accounts, then you'll likely be working, if not with organizations, then in one. So it's at least important to kind of know what's going on. All right. So AWS Control Tower is kind of a more recent service. And it was basically designed to be a more modern version of organizations that, again, helps you manage and create multiple AWS accounts. The biggest difference, though, is that organizations really just kind of monitors your accounts and says what's possible and kind of sees what's going on, with the billing and all that. But Control Tower can actively maintain and manage your account infrastructure. Okay, so you can set an account baseline, and Control Tower will basically prevent drift away from the baseline. And these baselines are based around what's called a landing zone, which are created from basically AWS well-architected best practices blueprints. And Control Tower works well with AWS Service Catalog to let your IT team build a stack of approved resources for end users to provision. Okay, again, Service Catalog just says what services are allowed to be used. All right, so you probably won't get asked much in depth about Control Tower. Personally, I haven't worked with it much, but again, it's, the key difference to kind of remember is that organizations is going to be more of a monitor for your accounts, and Control Tower is going to kind of actively maintain, your account infrastructure and configuration. Okay. So CloudFormation, when we talk about automation, CloudFormation is priceless. Okay. If you ever heard of like, Terraform or anything like that, infrastructure as code, this is kind of what we're talking about. And CloudFormation is a service that allows you to make templates to specify how you want your architecture deployed. Okay? So you can reuse templates to quickly deploy and edit your architecture configuration automatically. So instead of every time you need something to change or you need to modify something or deploy something, instead of doing it manually, you can just use these CloudFormation templates. Right? Uh, and then on that note, it helps eliminate user error when deploying resources. Maybe someone doing it manually accidentally puts in the wrong instance size or the wrong IAM permissions or whatever. You can eliminate all those problems by just using templates. Okay. So what that looks like is you create a template, or you just use one that you've already created. Okay. You save these templates in an S3 bucket. Okay. And then when it's time to use this template, you reference that template, and then it's going to create a stack based on this template, okay, which is then going to configure resources. So in this case, it looks like we have a VPC, and then we've got a couple subnets with a couple instances, maybe an internet gateway over here, maybe a load balancer. But instead of provisioning all this manually, once needed, you can just use a template, right? So maybe you've got like a failover scenario where you need to deploy all this architecture in a different region, okay? Because some of these resources, like your instances, are going to be region specific. Again, you could manually do it in another region, or you could just have it done automatically using this template, okay? So that's CloudFormation templates. They're very helpful for automating your services, your procedures, your deployment and editing of your architecture, okay? All right. AWS Config is a service used to manage changes in your AWS accounts and make sure they are compliant with processes set by your organization. Okay, I've taken this test, the Solutions Architect Associate test, multiple times. Every time I've been asked about AWS Config, at least once. Okay, it's region specific, so you're going to need to set your kind of config rules and settings in each region you want them to apply to. But some common use cases that you might consider AWS config for are to ensure, a resource or specific resources stay configured in a specific way. Again, maybe you have certain compliance requirements that your company or organization needs to meet. You can use config to keep track of all configuration changes to your resources. It'll create kind of a history of changes so you can see what was done. You can use it to list all the resources within a region. You can use it to, assist you with security analysis by detailing historical information and changes, which can be helpful for multiple reasons, like maybe auditing or, again, compliance reasons, okay? They really like to associate config with compliance, so that's kind of what I like to, the main use case I like to remember it for, all right? So again, config has a few different capabilities. It can capture resource changes, okay? It'll act as a resource inventory to kind of list things out for you from a high-level overview. You can store your configuration history to see what's happening and how things are changing. You can send notifications about changes, of course, using something like integration with SNS. You can audit your changes via CloudTrail, right? So use CloudTrail to see who did something. Right? You can ensure your resources, again, meet your compliance rules. Right? You can analyze your entire environment's security for compliance, so it's not necessarily just limited to a resource or two. And then it can also, as a side note, be really helpful to identify relationships and connectivity between your resources. So maybe, for example, you could see, if you had a network interface, you could see what instance it's associated with, what region it's in, what subnet it's in, things of that nature. Right? So config has a few components. I don't remember specifically being asked about too many of these, but it's good to know, at least from a high-level overview, what they do. So a config item is the key component that you're going to be using and working with, okay? It's a JSON file that holds the config and relationship information of a resource, okay? Config streams are basically what you get when a config item, okay, CI, is created. It's then sent to a stream as an SNS topic and to config, okay? The history is what we alluded to earlier that keeps track of changes that are made to resources. The config snapshot creates a config item of your current resources and then sends it to an S3 bucket. A config recorder is going to be the component that actually records all the changes in your account, and based upon that is going to generate configuration items, okay? It's another key component because it's going to be what's kind of recording things and keeping track of your CIs, okay, and generating your CIs. A config rule or rules are going to be what helps you enforce your compliance controls. It will alert you but not correct your resources. Okay, so that's important to remember is that it sends alerts that you can then use to send elsewhere, like maybe to CloudWatch, to actually do things. But config itself, these config rules are not directly going to correct your resources when something happens. Okay, they're just going to alert you. Permissions, config permissions are the IAM role that's needed for config to interact with other services so that it can do the appropriate kind of monitoring and recording. All right. So if we look here at the config flow, basically we have a configuration change that occurred here in some AWS resources. Right. So config is going to then record and normalize these changes into a consistent format, okay, using that recorder. And then two things are going to happen, all right? So normalized changes are going to be delivered to your S3 bucket, and then it's going to be accessed through your config APIs. And if you want, you can optionally send these changes, via SNS, so you can be notified of what's actually happening. Okay? And additionally, once we have this change that gets recorded, we're going to automatically evaluate the recorded configurations, okay, what happened over here against our desired configurations, which is what we have set up to say, we need our config and our changes and our resources to fall in line with this, okay? It's going to compare and evaluate what's happening to what's allowed, okay? Then once it does that, it's going to use a dashboard to display your evaluations to say if, things are in or out of line. And again, you can send notifications via SNS if something, for example, is not compliant. Okay, you can send it to yourself, you can send it to another service to do something about it. All right. And this kind of just updates or summarizes that a little bit if you want to step through it again. But AWS config is very helpful. It's going to discover pretty much all supported resources, which is just about everything that you would commonly be working with, instances, storage services, database services, things like that. And it's important to note too that after 6 hours, a config history file will be created for each resource type. So that's going to be, basically what keeps track of changes over time and allows you to see what's actually happening over time to your resources when changes are applied. All right. So let's take a quick break. And I believe that once we come back here, we are going to be able to finish everything up. So let's go ahead and take 5, and then we will come back and keep after it. Okay. here. So we've got AWS License Manager, which is going to be used when you have a certain software that requires a license to run, right? Like a bring your own license model. If that is the case, an AWS License Manager allows you to centrally manage these licenses, okay, and integrate them with your infrastructure. These licenses can be based on maybe virtual cores, so vCPUs, physical cores if you're using on-prem servers, sockets, or maybe the number of machines that you need to check your limits. And AWS License Manager currently works with, excuse me, EC2 dedicated instances, dedicated hosts, and spot instances. And additionally, it also works with Oracle databases and RDS, which is the most common place I've seen it being used for. Okay. You've got AWS Artifact, which is your one-stop shop for security and compliance reports. So if you ever need security and compliance reports, Artifact is the answer. A lot of these reports won't apply to you because they're like country specific. As you can see here, these are like for Australia, and these are for like European, like Europe, and then this is Cambodia. So not all of it's going to apply to you, but again, if you get asked about security and compliance reports, this is the place to go. Okay. AWS Systems Manager. This is a service that is designed to automate the configuration and ongoing management of your systems at scale. Okay? It supports EC2 instances, edge devices, and on-prem servers. It's going to provide you a customizable System Manager Explorer dashboard, so a nice visual tool, to help you kind of see your data and work items across different accounts and regions. So the more visual tools you can have, the better. Right? Best practice with Systems Manager is to use resource groups to select which resources to operate on. Similarly to like using IAM groups as opposed to individual like users. Okay. A resource group is, as you might guess, a collection of AWS resources in the same region that match a description. Okay. There are some requirements before you can use System Manager. You need to install an agent, which is just some software on an instance that you're going to use. It's called SSM Agent, and it comes with Linux and Windows AMIs. But it can also be installed, if you have some on-prem servers or even in other cloud providers. Okay? It is if you're using a managed instance, then you need an IAM role to communicate with SSM and then be displayed in your SSM dashboard. Okay, so you need IAM permissions just like you would with pretty much anything else. All right. So with logging, again, some key concepts. Okay, this is a little different than the management concepts we looked at earlier. Logging key concepts. First of all, it's best to use proactively. Okay, a lot of people don't necessarily want to pay for logs because you have to store the log files. Well, then just use lifecycle rules. Get rid of them after 30 days, whatever. But if you're not doing any kind of logging and something happens, how are you going to know what happens? Okay? You need logging to find out why something happened, who did it, what was affected. Okay, and also to analyze that for future reference so you can better secure, better prepare, better architect your infrastructure. Okay. Key logging services include CloudWatch, CloudTrail, CloudFront Access Logs, and then again, VPC Flow Logs. Okay? I said a lot of time at the beginning, we're going to spend a lot of time on CloudWatch and CloudTrail. So here we go. Just kind of quick recap of CloudWatch. Okay? What is happening to your architecture? That is CloudWatch. You can use what's called the CloudWatch agent on EC2 instances to get in-depth metrics and send back to CloudWatch. And then again, like we mentioned earlier, it utilizes log streams and groups. A stream is a sequence of log events with the same source, and then a group is a group of log streams that share the same retention, monitoring, and access control setting. Okay, so as you can see here, we've got a group of logs, and it's got some messages here talking about, it looks like we got some insufficient lake formation permissions, so we're trying to maybe create some kind of data lake, but we don't have permission to, something along those lines, running crawlers. But again, this is where you would go to actually see, oh, hey, this was a permissions issue, so I need to review my IAM permissions. Okay? But if you didn't have logging enabled, you would have no way of knowing that. All right. So CloudTrail, from a logging perspective, again, not necessarily a management perspective, a logging perspective, it focuses on who did something within your account and your resources. And it records, again, API requests that can come from CLI, SDK, other services, the console, and that stores as log files in S3. Okay, it records that metadata of the identity of a caller, the timestamp, and then the source IP address. That was weird. Let me get a sip after that one. So cross-account log aggregation is possible with the correct cross-account access permissions. So like if you had logging going on in multiple accounts and you wanted to just aggregate them all to the same bucket in one account, you could do that. So a log file structure, okay, we can actually visualize one here. And what we're looking at here is we are looking at an IAM user named teacher calling the describe metric filters CloudWatch API. All right. So as you can see here, we have a user identity object here, okay, which is an IAM user. It's got the AR in here, and as you can see, it's got it's a user named teacher with the associated account. It'll list their access key ID that they're using that I blocked out. And then again, it just kind of pulls the username out from this ARN, and it's going to show you the creation date of this, specific event, okay, by this user. All right. So the event time, as you can see, was on this date, and then it actually happened at 16:04 on server time. Okay. The event name, again, describe metric filters. It shows which region it happened in, the source IP address, and a whole bunch of other information here, right? And of course, you could parse these objects for analysis to see, maybe you have a specific API call that's getting made over and over again, and you want to see if it's from someone who's maybe doesn't have the correct permissions and they don't know that, or if it's like a malicious attacker, right? You can analyze your logs, which is very helpful for, again, being proactive, all right? So that's kind of what a cloud trail log file structure looks like. So hopefully that's helpful to help you kind of get a picture of what's actually being tracked and recorded, okay? So I've mentioned a few times that you can integrate CloudWatch and CloudTrail, and essentially what's going to happen is CloudWatch is going to ingest the API requests that are logged by CloudTrail, and then use SNS to be notified of significant events, like things related to EC2, or maybe a bunch of failed logins or failed authorization to certain services. And to set this up, you would create a trail that we looked at earlier that uses an existing CloudWatch log group, or maybe it just creates a new one. But creating a new one, a new log group rather, is recommended as the needed permissions are going to be automatically applied when you go to create that, okay? So CloudFront access logs allow you to record information for each user request that is requesting access to assets at your distribution, your CloudFront distribution edge locations, okay? So again, that's very helpful if you have like a malicious attacker trying to access your content and mess with it. You could see, those requests and the IP address, and you can maybe block that source IP address from accessing your distributions or something like that. But each distribution gets its own log, and then logs are stored in an S3 bucket, okay? So you have here a user, say in the European Union somewhere, and they sent a request to maybe get some stuff out of your CloudFront distribution. So that access from this user to this CloudFront distribution is going to be recorded, okay, tracked, and then uploaded to this S3 bucket as access logs, all right? And then if you want to sort of anonymize your logs, you can use a Lambda function to maybe do something to those logs for one reason or another, maybe for analytics, maybe for security and compliance. But the key takeaway here is that you can track, or log rather, user access to your CloudFront distribution so you can see what's going on, how they're accessing it, and things of that nature. Okay? So VPC flow logs are similar in that they work kind of within your network, right, within your VPC. So flow logs are used to capture traffic information that flows within your VPC, okay, against networking resources. And it can be things like a network interface that's on an instance, maybe some subnets, or the actual VPC itself. And you can publish VPC flow logs to CloudWatch groups for further analysis. All right. So you can see here, this is a set of flow logs. And then if you wanted to, you could expand these flow logs. But you can notice over here that it's got like some IP address information talking about the source of where something was coming from, some timestamps, action that was taken, right? So either it was accepted traffic or rejected traffic, okay? So flow logs can just be helpful from a networking perspective, all right? And then as you can see here, this is events for a specific network interface, all right? So now we've got our summary. Yeah, we can get through this here. We're gonna surpass an hour, but that's okay. We're almost there. All right. So CloudWatch, again, what is happening? CloudTrail, who did it? CloudWatch and CloudTrail are the main tools for logging and capturing events. All right. CloudTrail is going to give you a comprehensive view of what is going on with your applications and your infrastructure. It uses dashboards in the AWS console for visual displays of your metrics and alarms. Metrics are what let you monitor a specific element of an application or resource, like CPU utilization, for example. And alarms let you automatically implement actions based on thresholds configured against your metrics. So, for example, a 75% CPU utilization metric against an instance, and then you can use these alarms with SNS to send notifications out to end users or services when alarms and actions occur. Okay, an alarm state can be okay alarm or insufficient data. And EventBridge is actually going to be what connects to your apps to allow you to respond automatically to events as they happen. And then the CloudWatch agent is going to be what works with EC2 instances for detailed metric data. All right. Different services are just going to have different metrics, right? If you're monitoring EC2 instances versus like EBS volumes versus RDS instances, they're just going to have different metrics. Okay. CloudTrail, on the other hand, is again designed to record and track all AWS API requests that are made. These requests can be programmatic from an SDK, they can be from the CLI, again programmatic, or even from the console, or even from other AWS services. CloudTrail records various metadata about events, such as the caller ID, the timestamp of when something happened, and the source IP address. The records are stored in log files, and those are typically created every 5 minutes. The same with CloudWatch logs, and stored in S3. You can also send these records to CloudWatch logs to utilize automated responses. Right? Very helpful for finding the incident root cause, and it's also very helpful for security compliance audit reasons, as you can detect irregular patterns or even restricted API calls. Okay. AWS config is designed to record and capture resource changes in your environment. Okay? It's got a resource history that can track all the changes on a given resource. Okay? It can enable notifications via SNS on any of your resource changes, so you can be up to date with what's going on. It integrates with CloudTrail to track the source of your changes. Okay, it's very helpful with compliance specifically, as you can check the compliance of your resources and any changes against specific controls and policies that your organization may have set up. You can get an overlay of your networking relationships using config by identifying what resources are connected with one another. Okay, so you kind of get that networking layout of what's communicating with what. Okay. AWS organizations allow you to centrally manage and categorize multiple AWS accounts that you own. And it's very helpful for security and compliance in a larger multi-account environment. And the hierarchy includes the root account, organizational units, which can be nested, and then individual accounts. OUs let you categorize your accounts into things like maybe HR or dev or sales or test or whatever. Service control policies are exclusive to organizations and they allow you to set guardrails. So, what is allowed on all accounts, under where it is applied, right? So, each level of the hierarchy is going to inherit SCPs from the higher level on the hierarchy. But again, SCPs don't give permissions, they just say what is possible to be given, okay? Again, try avoid using SCPs on the root if possible because SCPs are hierarchical and they will inherit, lower levels in the hierarchy will inherit SCPs from higher levels. And you can deploy these with all features, or just enable consolidated billing. But if you want to use things like Firewall Manager, for example, you need to use all features. Okay. So VPC flow logs allow you to see the IP traffic going in and out of your VPCs. It's helpful in resolving communication issues within your network. And you can, of course, send this flow log data to CloudWatch to integrate with that as well. And flow logs can be created for network interfaces on an instance. They can be used on a subnet or even just the VPC as a whole. Okay. AWS Systems Manager is designed to automate the configuration and ongoing management of your systems at scale. Okay? It supports EC2 instances, edge devices, and on premise servers. Okay? It provides you a customizable System Manager Explorer dashboard to visualize your data and work items across accounts and regions. And it does require an agent, which is just software, to be installed on an instance, which is called the SSM agent. All right, so we made it through just over an hour, so not too bad. Hopefully that makes sense. Like I mentioned, logging is very important and it's best used proactively, okay? If companies are complaining about the cost of storing logs, then either move them to a cheaper storage tier or just delete them after 30 days. But either way, you should for sure be enabling some sort of logging solution in your architecture, all right? So hopefully that is helpful. And hopefully you have a great rest of the week. Don't forget to check out the labs. And we will see you next time in the next lecture.